Welcome to the show. Today, we're delving into a silent threat beneath our cities: land subsidence. It's the gradual sinking or sudden settling of the Earth's surface, and it's a growing problem for urban areas worldwide, leading to serious environmental and economic damage. So, what makes the ground sink? A big one is groundwater extraction. When we pump out too much water for homes, industry, or farming, the aquifers empty and the ground compacts. This could affect nearly a fifth of the global population by 2040. The sheer weight of our buildings can also compress soft soils. Natural consolidation, especially in coastal areas, adds to it. Underground mining and tunneling create voids that can collapse. Even tectonic movements play a role, though often more localized. And finally, the type of soil matters. Clay and silt are especially prone to compaction when water levels change or loads increase. How do we keep an eye on this slow creep? Geodetic monitoring is key. Interferometric synthetic aperture radar, or InSAR, uses satellites to detect tiny ground elevation changes with millimeter accuracy over large areas. Then there are global navigation satellite systems, or GNSS stations, providing precise 3D position data for specific points, great for long-term checks and validating InSAR. Traditional leveling surveys give accurate local subsidence data. LiDAR, often airborne, uses lasers for detailed 3D surface maps to spot elevation changes. Often, these techniques are combined, using advanced methods like Kalman filtering to get the most accurate picture of what's happening. Knowing the risk is vital. This starts with hazard identification. Mapping prone areas using monitoring data and geological info, looking at groundwater levels and soil types. Next is vulnerability assessment. How susceptible are buildings, roads, and people to subsidence? Then, risk quantification combines these to estimate potential losses, creating risk maps. So, what can we do? First, reduce groundwater extraction through regulations, conservation, and finding alternative water sources. Artificial aquifer recharge, basically injecting water back into depleted aquifers, can help. Better urban planning is crucial, with building codes that consider subsidence, especially in vulnerable spots. Reinforcing existing infrastructure and building flood defenses where subsidence worsens flood risk are also important. And finally, public awareness and collaboration between governments, businesses, and researchers are essential. This isn't just a local issue, it's global. Major cities from Jakarta and Manila to New York are affected. The impacts? Increased flood risk, especially in coastal areas where subsidence worsens sea level rise impacts. Damage to infrastructure like buildings, roads, and pipelines leads to huge economic losses and safety hazards. People can be displaced, economies disrupted, and there can even be health impacts like saltwater getting into freshwater. Projections show it's likely to get worse with more urbanization, population growth, and water demand, especially in developing countries. Climate change, bringing droughts and more groundwater pumping, will likely intensify it. So, land subsidence is a serious, pervasive challenge. Continued research, advanced monitoring, thorough risk assessment, and proactive mitigation and adaptation strategies are absolutely vital for the resilience and sustainability of our cities. Integrating data, using smart analytics, and international cooperation are key to tackling this silent crisis effectively.